Hi, I'm Singaravelu and the topic is glycopolymers for sensitive and selective detection of Escherichia coli. Application of sensors are wide. They are deployed in environmental monitoring, mines, industries, automobiles, household appliances, and in health assessment. Last but not least, in space exploration missions. What is sensor? Is a device on which a stimulus triggers a response. In chemical sensors, the substance binds to the transducer or signaling unit, and this event is a response recorded into an instrument. Few important parameters related to sensors are sensitivity, a measure of a method's ability to distinguish between two samples, reported as the change in signal per unit change in the amount of analyte. Sensitivity of analyte is equal to K, the proportionality constant, is equal to change in signal of the analyte over the change in concentration of the analyte. Selectivity is a measure of a method's freedom from interferences as defined by the method's selectivity coefficient. We know that a signal of a sample comprises of the analyte and also the interference, which can be written in terms of mathematical terms as sensitivity of analyte times the concentration of analyte plus the sensitivity of interference times the concentration of the interference. A measure of a method's sensitivity for an interferent relative to that of the analyte is given by K subscript A, I, which is equal to sensitivity of interference over the sensitivity of analyte. Lower detection limit is a statistical statement about the smallest amount of analyte that can be determined with confidence. Stability, reusability, short response time, low cost, fast and reversible interactions with analytes, simple to use in the field, are the requirements for sensors. Fluorescence is the emission of light at a different wavelength, slightly higher than its absorption wavelength. The molecules absorb light, and due to that, electrons get pumped to lowest unoccupied molecular orbitals. There, due to internal conversion, they relax to lowest energy level of the lowest unoccupied molecular orbital. From lowest unoccupied molecular orbital, it relaxes to the ground state by emitting the light. When intersystem crossing occurs, it forms a triplet and then relaxes to ground state by phosphorescence. Polymer A is a fluorine-based conjugated polymer with oligoethylene glycol side chain with beta-glucose pendant. Polymer B is also fluorine-based conjugated polymer with polyethylene glycol side chain with beta-glucose pendant. The difference in polymer C is compared to polymer B is the pendant group alpha mannose. Alpha mannose binds specifically to ORN 178 strain of Escherichia coli due to the presence of FIM-A or FIM-H gene cluster Here we see the absorbance spectrum of polymer C alone in blue line and the absorbance spectrum of polymer C with the Escherichia coli ORN 178 strain. We could notice that the fluorescent cell cluster have a red shift and the absorbance peak maximum is close to 400 nanometer, which is around 10 to 20 nanometer higher than the polymer C itself. In the next one, now we see the normalized fluorescence intensity of polymer C alone, which has an emission peak maximum at 425 nanometer, whereas the fluorescent cell cluster of polymer C with the Escherichia coli has a broad emission peak starting from 425 to 470 nanometer. This redshift is due to the aggregation of polymer C with the Escherichia coli bacteria. So, with polymer C, we could stain the E. coli bacteria, and here we see about 1 into 10 to the power 8 of such E. coli cells, resulted in a redshift. The UV visible absorption, the fluorescence spectrum, both showed the redshift, and the excitation wavelength used here is 370 nanometer. The results were published in Chemistry, a European journal. Thank you very much for your attention, and I would like to acknowledge my postdoc advisor, Dr. Kazuhiro Takanabe, Professor Zheng, PhD advisor, Professor Liu, dissertation committee members, Professor Lo Fang, Professor Yap, and other graduate members who worked with me, Dr. Steve, Dr. Ratu, Dr. Shwe, Dr. Chuha Lee, Dr. Venkat, Dr. Giri, and Dr. Meng. And I would also like to thank Professor Sarah Green, Professor Michelle Miller, Professor Paul Bergstrom, Professor Andrew J. Mason, Professor Pushpa Murthy, and Professor Susan Bagley for all their help and support. Thank you very much. Please let me know if you have any questions.